What's the next number after 1, 3, and 5? If you say 7, I say it's correct. If you say it's any number, it's also correct. Not just 7, 8, 9, 10, whatever number, also correct. The reason we say it's 7 is because we can construct a linear equation. A 2x, because each number differs by 2. Right? First number 1, second number 3. So minus 1. X is equal to 1. Y is equal to 1. X is equal to 2. Y is equal to 3. X equal to 3. Equal to 5. X equal to 4. 8 minus 1 equals 7. Right, that's the justification. Now I say, next number, for example, is 8. Also correct. As long as I can construct a cubic equation function. And that's my justification. Plus d. That happens to go through the 4 points. That is x is equal to 1 and y is equal to 1. X equal to 2, y is equal to 3. X is equal to 3, y is equal to 5. X is equal to 4, y is equal to 8. Those 4 points. Can I construct such a cubic function? If I can, then I have my justification. If you plug in any number, 8 replaced with some number x. If you can somehow, s some number, construct a cubic function. How I'm going to construct that? I say, first of all, take 1. So 1 minus 2 times 1 minus 3 times 1 minus 4. Okay. Top I have x minus 3 times x minus 2, x minus 3, x minus 4. Okay. Plus, I'm going to take 2. 2 minus 1 times 2 minus 3 times 2 minus 4. Going to multiply by 3. X minus 1 times x minus 3 times x minus 4. Plus, I'm going to take 3. 3 minus 1 times 3 minus 2 times 3 minus 4. Top I have 5 times x minus 1 times x minus 2 times x minus 4. Plus times 8. Right? Here I take 4. 4 minus 1 times 4 minus 2 times 4 minus 3. Here I have x minus 1 times x minus 2 times x minus 3. Okay, here's my cubic equation function. Right, I say it passes through those 4 points. Why? Because when x is equal to 1, I have 1 minus 2 cancel with this. 1 minus 3 cancel with this. 1 minus 4 cancel with this. So this term becomes 1 when x is equal to 1 in this case. Right? So this becomes 0. Gone. Gone. 0. Gone. Right? So y is equal to 1. When x is equal to 2, what do I have? This becomes 0. This becomes 0. This becomes 0. Right? This becomes what? 2 minus 1 cancel with this. 2 minus 3 cancel with this. 2 minus 4 cancel with this. 3 times 1. Y is equal to 3. When x is equal to 3, this is gone, so this is gone. This is gone. This is gone. This is gone. So I only have this. 3 minus 1 cancel with this. 3 minus 2 cancel with this. 3 minus 4 cancel with this. 1 times 5. It's really 5. When x is equal to 4, likewise, this is gone. This is gone. This is gone. This is 4 minus 1, cancel with this. 4 minus 2, cancel with this. 4 minus 3, cancel with this. 8. So really passes through these 4 points. So just to be really sure, to be really convinced, we could even further simplify that down to turn it into this standard form of a cubic function. Right? Perhaps I say, okay, here's what do I have here? Negative 1. Okay, negative 1. Negative 2. Negative 3. Fine. Turns out to be negative 6. Here is 1. There is a negative 1. There is a negative 2. So turns out to be just 2. And here is 2 times 1 times negative 1. Looks like it's negative 2, right? So here's 3. There is 2. There is 1. So turns out. So I finally simplified that down to this, but we still want to simplify the top. And so now we just say, simply expand those two first. X squared minus 3 minus 5 x plus 6 times x minus 4. That's the first term. Second term plus over 2, 3 times x squared minus 4x plus 3 x minus 4. Okay. Third term, negative 2, 5 x squared minus 3x plus 2 times x minus 4 plus 6, 8. Perhaps simplify down to 3 and 4. Right, so 3, 4 x squared minus 3x plus 2 times x minus 3. Okay. So further simplify. Negative 6. Now we just focus on the cubic term. So cubic term is just this. Square term, what are they? First of all, I have this times this, negative 5. Then I have this times that, negative 4. So negative 9. Then x term. X term is what? This times that, plus 6. This times that, plus 20. So plus 20, 26. Constant term is just this times that, negative 24. Right? So likewise, here we have cubic term. Square term is what? This times that, negative 4. This times that, negative 4, negative 8. X term, this times that, plus 3. This times that, plus 16, so plus 19. Constant term is this. Okay. Plus negative 2 times 5. Cubic term. Square term is this times that, negative 3. This times that, negative 4. So altogether, negative 7 x squared. And x term would be this times that, so 2. This times that, 12. So plus 14 times x. Constant term is negative 8 plus 3, 4 x cubed. This times that, negative 3. And this times that, negative 3. So negative 6. X term is this times that, so 2. This times that, 9. So plus 11. X constant term, negative 6. Okay, now we focus on the coefficient of, for example, cubic term. What's the coefficient? I look at, first of all, negative this. Okay? So from here I have 3 over 2. From there I have negative 5 over 2 plus 4 over 3. Turns out to be 6, negative 1 plus 9 minus 15 plus 8. Okay, that is what? So 9 plus 8, 17. 17 minus 16, and it's 1. 1 over 6. So square term coefficient is what? So negative 9, negative 6. So positive 9 over 6. So positive 3 over 2. From here, negative 4 times 3, negative 12. Negative 12. From here I have positive 5 times 7, 35 over 2. 35 over 2. From here I have minus 6 divided by 3, 2. 2 times 4, 8. Minus 8. That would be fractions together. 38. Integers, minus 20. Okay. That is 19 minus 20. Negative 1. Coefficient of cubic term is 1 over 6. And for square term is just negative 1. So coefficient for x term is what? So from this term I have negative 26 over 6. So maybe simplified. Negative 13 over 3. So from this, so 3 times 19, 57. 57 over 2. Okay, 57 over 2. And from this term is a negative 14 over 2, 7. So negative 35. From this term, bracket. For this term is 44 over 3. Okay, 44 over 3. Okay, it's the what is that? This combined together is 44 over 30. Okay, 31 over 3. Not simplify. Common denominator is 6. Perhaps let's just use. Okay. Common denominator is 6. So negative 26. Maybe shouldn't have simplified that step, but anyway. So plus 57 times 3. 171. And this times 6 is what? 210. And this times 2 is 88. Okay, so looks like it's this plus that is okay, 259. 259. Yeah. So negative. So this negative 236. Still positive. So what is it? 23 over 6, not simplified. Right? But that's fine. So constant term is what? This over that. So positive 4. 3 times this over that. So this over that, negative 6, negative 18. This, negative, positive. This over that, 4. 4 times 5, 20, plus 20. Also, this term, or this over that, negative 2, negative 8. That would be 24 minus 26, it's negative 2. So far we reached the coefficients of all the terms. So use the standard form, cubic equation is times x cubed minus x squared plus 23 over 6x minus 2. And that's the cubic function that we have that happens to go through those 4 points. And just to be really convinced, let's double check. Right? So check what is f1. Is it really equal to 1? So 1 over 6 minus 1 plus 23 over 6 minus 2. So that is equal to, fractions go together. 24 over 6, integers, negative 3. What is that? 4 minus 3, 1. So that is good. What is f of 2? Is it really equal to 3? So 1 over 6 times 2 cubed, that's 8. Minus 2 squared, that is minus 4. Plus 23 over 6 times 2. 23 times 2 is 46 minus 2. Okay. Maybe simplify that. Perhaps I'll. Okay. Fractions. 8 over 6. Here, 46 over. So plus 46. Integers minus 6. That is 54. 9. So 9 minus 6. Yes. Yeah. Okay. So what is f of 3? Is it really equal to 5? 1 over 6 times 3 cubed is 27. Minus 3 squared minus 9 plus 23 over 6 times 3. Right? And minus 2. What is that? Okay. So 26 or 27 over 6. So 9 over 2. Right? This is what? This 23 over 2. And this negative 11. So what is that? 32. Right? 32 over 2 minus 11. 16 minus 7. Yes, really is equal to 5. What is f of 4? Is it really equal to 8? So 1 over 6 times 4 cubed, that is 64. minus x cubed minus 4 cubed, that is minus 16, plus 23 over 6 times 4, then minus 2. Okay, what is that? 64 plus 4 times 20, 92, I believe. Integers, negative 18. Okay, what is that? $156. Okay. 2 times 6, 12, 36. 26 minus 18. Yes, really 8. So this really justifies, perfectly legal, really justifies. That's, like I said, justification for number 7, following those 3 numbers, that we have a linear function that happens to passes through, goes through all the 4 points, right? If it's 8, right, then we can construct a cubic function whose graph happens to go through all the 4 points, right? Easily justified. And of course, the technique we here used is called Lagrange interpolation.